Today we will discuss some problems related to refraction and total internal reflection. So in the last video we discussed about refraction and total internal reflection. So here we can discuss some problems related to that. Okay. So we'll start with our first question. The refractive index of water is 1.33 and the refractive index of glass is 1.5. If the speed of light in water is 2.25 into 10 raised to 8 meter per second, calculate the speed of light in glass. So here both refractive indices are given and speed of light in water is given. We have to find the speed of light in glass. So you know the formula, no? Refractive index, formula you know, N is equal to C by. So here we can write for first case, refractive index of water is equal to C by velocity of light in water. Similarly, we can write refractive index of glass is equal to C by velocity of light in glass. Okay. So 1 divided by 2. What you will get? Equation 1 by 2. If you do, you will get refractive index of water by refractive index of glass is equal to C by VW into VG by C. We will get cancelled. So Vg is equal to, Vg means velocity of light in glass is equal to Nw by Ng into Pw. Nw refractive index of water is given 1.33 divided by 1.5 into 2.25 into 10 raised to 8. So if you simplify, you can see that you will get approximately 1.95 into 10 raised to 8 meter per second. Okay, 1.95 into 10 raised to 8 meter per second. Clear? Now we will discuss the next problem. Okay. A light of wavelength 6000 angstrom in air enters a medium of refractive index refractive index 1.5. Calculate the wavelength and frequency of light. Calculate the wavelength and frequency of light in that medium. So here what is given? Wavelength is given. No? Wavelength in air is given and refractive index is given. You have to find the wavelength and frequency of light in that medium. So first of all you can find frequency. How to find frequency? Frequency is equal to C by lambda. C is 3 into 10 raised to 8 lambda is 6000. What you will get? 2000. So 1 by 2, 0.5 into, and here it should be, wavelength should be converted into, angstrom should be converted into meter. So 1 by 2 is 0.5. 10 raised to minus 10, it will become 10 raised to 18 minus 10. When it will go to numerator, it will become 10 raised to 18. Here minus 3 is there. So what you will get? 10 raised to 15. Or you can write 5 into 10 raised to 14 Hertz. This is the frequency in air. Same frequency will be there in frequency remains same. No? I told you, when light travels from one medium, to another medium, the only one thing remains same is frequency. So in air, whatever the frequency, the same frequency will be there in this also. Now you can calculate the wavelength and frequency of light in that medium. Now you can find wavelength. How to find wavelength? You know that refractive index is equal to C by B. And C can be written as F into lambda divided by F into lambda dash. Lambda dash means wavelength in that medium. Wavelength of light in that medium. Okay. Frequency can be cancelled. So n is equal to lambda by lambda dash. So this is another relation between between refractive index and wavelengths. N is equal to lambda by lambda dash. Actually we are getting from this relation only. So what it is given? Lambda is given, n is given. We have to find lambda dash very easy. So lambda dash is equal to lambda by n. Lambda is 6000 angstrom divided by n is 1.5. What you will get? 4000 angstrom. 6000 by 1.5 will get 4000, and angstrom itself like that only we are representing. We are not writing it as 10 raised to minus 10 because here it is wavelength itself. That's why no need of conversion. Directly you can write like that. Okay. Now we will proceed to the next problem. The apparent depth of an object in a tank filled with a medium of refractive index with a liquid. You can write medium of refractive index 1.3 is 7 centimeter. Calculate the actual depth. Calculate the actual depth. So you know the relation, refractive index is equal to real depth divided by apparent depth. So here refractive index is given, apparent depth is given. You have to find real depth. So you can write real depth is equal to n into apparent depth. Refractive index value is given 1.3 into 7. It is given in centimeters. You can write 7 centimeter. So what you will get? 9.1 centimeter. Okay. So actually it is 9.1 centimeter, but it appears to be 7 centimeter. Okay. Is it clear? So shall we discuss the next problem? Okay. How much would an ink dot appear to be raised if a glass slab of thickness 6 centimeter is placed above it. Given the speed of light in glass is 2 into 10 raised to 8 meter per second. So here refractive index of glass is not given directly, so we don't know that which type of glass is there. Various types of glasses are there, crown glass, flint glass, like that. So many varieties of glasses are there. Since it is not specified, it is not given that refractive index and already given that speed of light in glass. So first of all, we can find the refractive index. So what is the formula? Refractive index is equal to C by V. C is the 3 into 10 raised to 8. V 2 into 10 raised to 8. 3 by 2, what you will get? 1.9. You got the refractive index 1.9. Once you got refractive index, you can find the apparent depth. How to find apparent depth? Refractive index is equal to real depth divided by apparent depth. No. So apparent depth is equal to, we can write, apparent depth is equal to real depth divided by refractive index. Real depth divided by refractive index. And what is real depth? Actual depth it is given that we are keeping a glass slab of thickness 6 centimeter. So 6 divided by refractive index we calculated 1.5. What you will get? 60 by 50 which is equal to 4 centimeter. Because here we are writing, we are not converting 6 centimeter, that's why we can write 4 centimeter. Now what we have to find? How much would an import appear to be raised? So here you have to find the normal shift. No. So normal shift is equal to real depth minus apparent depth. Minus apparent depth, which is equal to 6 minus 4, that is equal to 2 centimeter. So it will be appearing to be raised by 2 centimeter. Okay, is it clear? Now we will discuss the next one. The critical angle for a medium of refractive index So here what you have to find? You have to find the critical angle. Its refractive index is given. So direct formula is there. What is the formula? Refractive index is equal to 1 by sin C. So n is given. So root 3 is equal to 1 by sin C or we can write sin C is equal to 1 by root 3, or C is equal to, how we will write? We can write sin inverse 1 by root 3. So you can simplify this. Root 3 value you can substitute it as 1.732 and 1 by 1.732 you can find it, and corresponding to which that angle is there. Corresponding to this value of 1 by root 3, after doing that calculation you can see in that class table corresponding to which value of sine, for which angle of sine that value is there, that you can know. Okay, so we will discuss the next one. Calculate the speed of light in a medium whose critical angle is 30 degrees. You have to find the speed of light in that medium. So we know that refractive index is equal to 1 by sin C, and again we can write refractive index is equal to speed of light in vacuum by speed of light in medium. Okay, is it clear? So what it is given, n is equal to 1 by sin C, so you can substitute 1 by sin 30. Sin 30 is 1 by 2, so 1 by 1 by 2, we get it as refractive index is equal to 2. Now you can substitute here n is equal to C by V. What is C? C is given 3 into 10 raised to 8 divided by V is equal to 2. So we can find V is equal to 3 into 10 raised to 8 divided by 2, which is equal to 1.5 into 10 raised to 8 meter per second. Okay, is it clear? Now we will discuss the next one. In the following diagram, or from the following diagram, better we can write in the note, from the following diagram, calculate from the following diagram, calculate the speed of light in the medium. Calculate the speed of light in the medium. Okay, so here diagram is given like this. So normal, from here light is traveling, it just grazes through the surface. Grazes through the surface means this is the, and this angle is given I. This is the diagram. So how, and here it is given that it is 400 centimeter and this is 300 centimeter. This is not mentioned here, we can mention that this is a critical angle. Why? Because ray is just grazing through the surface. So this angle will be, angle of refraction is 90 degrees. Since angle of refraction is 90 degree, this angle will be critical angle. Okay. So we can write, how to write this, you can, instead of IC you can write C also. Okay. So first of all we have to find from this triangle ACB, we have to find sine C, no, sine IC or sine C. How to find sine IC? Sine IC we can find So this we can write it as IC, or if you want you can write critical angle C itself, okay. Because we have discussed that only, no, C also you can write, not a matter. So we can write instead of sin IC, we can write sin C itself. So sin C we have to find. How we can find sin C? Sin C is equal to opposite side by hypotenuse. Opposite side is AC. AC divided by hypotenuse is BC. But BC is not given. You can find BC. How to find BC? BC square is equal to AB square plus AC square. So that can be written as 4 square plus 3 square, which is equal to 16 plus 9, 25. Or we can write BC equal to 5 centimeter. Sorry, 5 centimeter, not 5 meter. Okay. 500 centimeter or 5 meter. We got BC. Once we got BC, we can find from that sin C is equal to AC. What is AC? AC is equal to 3 meter divided by 5. So sin C is equal to 3 by 5. But what we have to find? We have to find the speed of light in the medium. Okay. And we know that refractive index is equal to 1 by sin C. And refractive index can be written as C by V. Okay. What we have to find? V. So V is equal to C into sin C. Can we write? C is the speed of light and sin C corresponds to critical angle. Okay. C is given 3 into 10 raised to 8 into 3 by 5. What you will get? 9 by 5 into 10 raised to 8. So we can write it as 1.8 into 10 raised to 8 meter per second. Okay. Is clear? So this is the way of solving problems related to critical angle angles. Similarly, still some more problems are there. You can go through that. Especially regarding barrier, I told you immiscible media will be there one over another. So in each you have to find T into 1 minus 1 by n plus T2 into 1 minus 1 by n plus T3 into 1 minus 1 by n, like that problems are there. Similarly, problems related to glass slab also, T sec r into sin I minus r. Based on that also questions are there that you can refer and you can solve. Okay. So today we solved some problems related to refraction and total internal reflection, especially based on critical angle. I hope all of you understood. If you are having any doubt, contact me. Okay. Thank you.